If you're watching this in spring of 25, I've decided to cut the alternative polar equations for ellipses and hyperbolas. They're really not necessary. It's just a different way to write the same thing, so we won't be bothering to look at that. It's just not necessary. All right, so let's look at example. This is going to be 15. Consider the polar equation r equals 32 over 3 plus 5 sine theta. Identify the conic and find the eccentricity, the vertices, both foci, both directrices, and asymptotes, if any. Give values in both polar and Cartesian forms. Okay, so if we look at r is 32 over 3 plus 5 sine theta. Now we just saw the trick to this, which is to multiply by, in this case, oops, 1/3, sorry, not 1/5, 1/3, because you want that number in front to be a 1. So you're going to take a third and a third times both of these things. That will get you 32 over 3 over 1 plus 5/3 sine theta. Okay, so we know E times D is equal to 32 over 3. And we know our eccentricity is 5/3. So this piece right here tells us the eccentricity is 5/3. Done. Because it's always the thing that's multiplied by either the sine or the cosine. Sorry, that got weird there, so let me try to write that again. All right, I can box that. That's one answer already done. Now, because my E is greater than 1, I can tell this is a hyperbola. Now, I can also tell, because it's sine theta, that this is an up-down hyperbola. Right? If we look at the general forms, when you have sine, those will be of up and down, top and bottom. Now we think, generally speaking, about what that picture would look like, just real quick. We're going to have the origin right here, right? We're going to have some kind of hyperbola going with a focus at the origin, like that. Right? It's going to look like that general shape, which means it's going to have vertices on pi over 2, pi over 2, and 3 pi over 2. Just keep that in mind. Actually, let me make this clear. On theta equals, right? Because this is polar. And it's written right here, right? Theta equals pi over 2, 3 pi over 2, right? So you're going to have one getting you one and one getting you the other. All right. So now let's find our directrix, shall we? So we know that E times D is equal to this piece over here. So that's ED. And we know what E is. It's right here, right? So ED is equal to 5/3 D, which is equal to 32 over 3. That means that D is equal to 32 over 5. Well, here, what I'm really doing is 32 over 3 times the reciprocal of this, 3/5, which makes 32 over 5. All right, so that's D. So D is 32 over 5. That means that my directrix would be Y equals 32 over 5. Directrix done. All right, now let's see, what about our vertices? So the vertices happen on pi over 2 and 3 pi over 2. So the vertices are of the form r comma pi over 2 and r comma 3 pi over 2. It has to be. So let's look at theta equals pi over 2 for starters. That would make r equal to 32 over 3 over 1 plus 5/3 sine of pi over 2. Oh, I should say you could put it back into the original. You don't have to put it back into this modified version. I just did without thinking about it, but it's fine, you know. All right, so this will be 32 over 3 over 1 plus, all right, the sine of pi over 2 is 1. So that's 1 plus 5/3, which is 32 over 3 over 8/3. The 3's will cancel because they're both in the denominator. So it's 32 over 8, which is 4. So that means that I'm going to have, in polar form, I would have pi over 2, oh, r comma pi over 2, so 4 comma pi over 2, like that. Okay, so let's think about where that is for just a second here before I go any further. So pi over 2 is this line right here. This is pi over 2. So I would go to the angle pi over 2 and I'd go up 1, 2, 3, 4. Now this is 10 here. So 2, 4 is right here. So that's vertex 1. All right. Now I know I need that in rectangular form also, but let me box that because that's one vertex found. Now rectangular, I'll just kind of put near it because rectangular is easy. Rectangular form of that point is over 0 up 4. There we go. All right, so I have my rectangular kind of thrown in there. All right, now let's do it again with theta equals 3 pi over 2. R equals 32 over 3 over 1 plus 5/3 sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. So this is 32 over 3 over 1 minus 5/3, which is 32 over 3 over negative 2/3, which is 32 over negative 2, which is negative 16. So that means my other polar vertex is negative 16, 3 pi over 2. All right, let's think about where that is. All right, so this is V1, this is V2. Okay, so 3 pi over 2 is here, but then we're going backwards. We're going negative 16, which means we're going, instead of going down 3 pi over 2, we're going up. So there's 10, 12, 14, 16. There's vertex 2. Okay, so if I want rectangular for that one, I can fit it in right here. The rectangular would be 0, 16. All right. Now, what about the foci? Okay, so for the foci, we know that the origin is focus 1 automatically. Right? That is just how these are built. Now let's think about that for a second. Focus 1 is here. It is 4 units away from vertex 1. That means that focus 2 has to be 4 units away here. So focus 2 has to be here because this is 4 units here and that must be 4 units there. Oh, so let's make a note. So from focus 1, well, vertex 1 to focus 1 is 4 units. That means that from V2 to focus 2 must also be 4 units. And that means that focus 2, so this is focus 1, I can box it, right? But focus 2 would be 0, 20 in rectangular coordinates, right? I'm just going to do that in rectangular. I'm not going to bother. So this is rectangular. Technically, it's polar also. So this will be 0, 20 in rectangular coordinates. Actually, you could argue it's pi over 2 would be the angle, and it'd be 20. So if you want polar, polar is the same as this, right? Polar and rectangular for the origin are 0, 0, so it's the same. But if you want polar for this one, it would be 20 comma pi over 2, like that, because you're on the pi over 2 radial coming out of the origin. Now what about the directrices? So we know that one of them is at y equals 32 over 5, which is about 6.4. So if I go 2, 4, 6, 6.4. So I have one directrix right here. That's y equals 6.4, or 32 over 5. So I'm going to have another one the same distance away, right? So whatever this distance is from the origin up to that directrix, it's going to be the same as this distance from the focus up to that directrix. It's going to be the same from the other focus down to this directrix. So I'm going to have another directrix right here, right? Okay, so let's see. So F2, right, focus 2, take away D must be equal to, well, F2 is at 20, take away, and then I know it's 32 over 5, right, because it has to be the same distance. So in other words, this distance is 32 over 5. So this distance has to be 32 over 5. So what I'm doing is I'm taking the 20 and I'm subtracting 32 over 5 to get here. So 20 take away 32 over 5. Well, let's see. 20 is 100. 100 take away 32 over 5 would be 68 over 5, which is about 13.6, which is about where it looks like it's on the graph. So there's your other directrix. Y equals 68 over 5, or 13.6. Other directrix is found. All right, then it also wants the asymptotes. Now, to find the asymptotes, we're going to need A and B, right? Because that we don't have any polar form, because those are diagonal lines. So let's think about the length of the major axis. So the major axis is going from, and actually let me draw these graphs just so you know, this is a hyperbola, so it's doing something like this, right? I've been avoiding drawing the curve because it kind of doesn't matter, but there you have it. All right, so there you go. It's terribly drawn, but there you have it. So it's this curve. Okay, so the major axis is the distance between the vertices. So the major axis is from 0, 4 up to 0, 16. So that means that it's a length of 12. But that's also 2A, and that means that A is 6. Okay, now the minor axis b squared equals a squared times e squared minus 1. Now if you're wondering, where in the world did that come from? We already had it, right? It's properties of ellipses and hyperbola centered at the origin. When you're dealing with a hyperbola, b squared is a squared times the eccentricity squared minus 1. All right, it was right there. Okay, so, but I know that a squared is 6 squared. So that's 36 times e squared, but I know what e squared is. E is, I found e a long time ago. It's up here. It's 5/3 right there, right? So I can put that in. So that's 5/3 squared. Take away 1. Okay, so that's 36 times 25 over 9, take away 1, which is 36 times 36 times 16 over 9. 9 goes into 36 4 times. 4 times 12 makes 64. So if b squared is 64, that means that b is 8. Wonderful. Now, how has this helped me? Well, because we have formulas for the asymptotes. The slant asymptotes of a vertical major axis hyperbola would be y equals plus or minus a over b, x minus h plus k. So I got to write that. Okay, so the slant asymptotes be y equals plus or minus a over b, x minus h plus k. So for us, y equals plus or minus 6 over 8 x minus 0 plus 0. That means that the asymptotes are y equals plus or minus 3/4 x. Oh no, our k is not 0. Our k is 10. Sorry, I can't read my own handwriting. Let's talk about that real quick, because we never said it. I don't think I ever wrote it anywhere. The center is not at the origin. The focus is at the origin. So let's make a quick note here. I'll put it up here. The center, can you see it? It's right there. So the center, and I don't know if I ever asked for it anywhere, but I'm going to put it somewhere. Center. I should ask for it. I'll add it to the list. The center is 0, 10. Which, if you want that in polar form, it would be 10 comma pi over 2. I didn't ask, but if you want it in polar form, it'd be 10 pi over 2, right? Because you're on the pi over 2 axis and you're up 10. All right, so that's why this is plus 10 down here. All right, our k is 10. Our h is 0, but our k is 10. So there you can see I graphed it in Desmos. I have the directrices, and the points, the foci and the vertices and the center, and then there's the asymptotes. Just like we said they would be. Right, you can see that the equations are making the graphs work out.